data systems. We're a Microsoft Gold partner, specializing in Office 365 as well as Azure, or they call it Microsoft 365 and Azure. Just this last year, we won several awards for security and compliance. Right, so our focus is security first, and then we look at what you can do in the cloud. So there's a lot you can do in Azure. Alex will be talking today about one of the thousands of services in Azure, and how you can apply some of those services to ultimately come up with real-life business solutions and solve those business problems. In the room with me, I have Keith Ginsburg, who's one of our senior account reps, sitting over there. Stuart Landy, our...
I just wanted to say one thing.
Sure.
Something. So the reason we put this together is we've discovered we've been working in the cloud for quite a while now, specifically with Microsoft, but with other cloud providers as well. We discovered that over, I guess, 50% or 55% of data is dark in corporations. And actually, most of the people involved don't even know where it is. And it turns out that that's the new next oil for corporate America. That's the goal. We thought we'd do this frequently. If we can get on our list, we bring in subject matter experts that we work with, that we partner with, to shed light and give more information about this new transformation that's happening as we speak. I just want to tell you why we put this together. Ultimately to attract you as customers, but we like to do content marketing process to do it.
I'm Maureen Landy, president of Maureen Data Systems, and his vision was over 5 years ago. We were with this company called Fastini, which was the email system. And everybody laughed at us and say, oh, we're not going to go to the cloud, we're not going to do this. And sure enough, 5 years now, 7 years now, mostly everybody's going into the cloud using email, Office 365. So the vision of going to AI is the right vision that I see for us to do.
And I think that's everybody from the MDS side. So Alex, you want to...
So my name is Alex Plies. I'm the CEO owner of 5Element Analytics, and my team is outside. Brought them in case there's any more questions to make sure they had chairs. You guys had chairs. I'm also a faculty member. I'm an associate professor at Hofstra University, where I teach some advanced statistical topics, data mining, multivariate statistics, and so forth. So for those of you who just panicked, there's no statistics in here, okay? Because that usually happens to a lot of my students. They all start panicking about it. What I'm hoping to get out of this for you, thank you for all the information that you provided. It is very difficult when you have a very disparate group that's trying to figure out different things of machine learning and artificial intelligence and all the buzzwords that go on. If you have a question, stop me right away so I can answer it, because I'm sure someone else has the same question, and it'll help the presentation move along pretty quickly. So I only have 2 slides about us, if I can get this right. Or not. Let's see if this goes now. There we go. So one of the things is our approach. Whoops, this is not going to work. There we go. So one of the things is our approach. Our approach is fundamentally different than a lot of other companies. So for example, you have Amazon that has their artificial intelligence services or machine learning services. You have IBM, same thing. A number of times we've actually beaten specifically the IBM solution, only because of this. They have these wonderful systems that take all your data and give you a result and say, here you go. But the machine can't tell you why. There's no analysis behind it. There's no intuitive knowledge that says internally, these are the variables that you need to keep. This is what you need to know. Here's how you can make it actionable. And so ultimately, we realized a while ago that there's 2 aspects to this yin-yang of data science. There's the mathematics, which is the objective view. It is the numbers behind it. But there's also the subjective view, which is the intuition. There are data points that your internal group already has because they've experienced it. So we bring that into the equation, and we can codify that and see how that helps inform the entire solution, wherever it is. Our principle is based on the Chinese 5 elements. Basically, the first thing is you need the right people in place. That's Earth. That's your foundation for everything. The second part is tools, which is the metal in the Chinese elements. And that is basically, we're tools agnostic. We don't really necessarily care what the tools are, whether it's SAS or R or Python, doesn't matter to us because it's all about the process and it's all about getting to the right solution. The third one is data or water. Data is amorphous. So you get a ton of data. It's going to take different shapes. If you put it in this one large vessel or one large bowl or a very thin glass, it will take different shapes. It is up to the analyst or the data scientist to really understand what it is they're looking at. The fourth one is process. It's wood. There is a process behind this. There is a methodology. It's not dump all the data in, we'll see what comes out. That doesn't help anybody. And the final piece is action. One of the things that we do with all our clients is, what are you going to do with this? Otherwise, it's an academic exercise. And if we were going to do that, I could just publish papers at Hofstra and, I'll be fine. That's all I need to do. But it's about the action. What are you going to do with it? Because it helps inform the proper analysis that you're doing. This is a list of clients that we've specifically worked with. The partnership that we're developing with Marine Data Systems is important because they're offering a lot of the services which data science sits on, right? The Azure, the cloud environments, being able to monitor those things and monitor the solutions is actually very critical. In about half of our clients, it was put onto a cloud environment. So it's important to have a really strong cloud partner who's going to basically be able to size up and scale. If you're doing training models, you may need a little bit more processing power for a short period of time. When you go into production, you can actually bring down your training system and actually put it into production a little bit different. Did you want to talk anything about your other clients or?
No, I don't know if we have a slide there for it. But,
No.
Like Alex said, I mean, a lot of our clients look to see which platform they can leverage, all right, whether that's PaaS or IaaS, to basically allow for a lot of these data analytics services that you want to run in your environment. And so Azure is our go-to choice. Being a Microsoft partner, we do work with other providers as well, but Azure being the leading one.
Okay. Now you see some of these companies very large. They have large amounts of data. In many cases, we dealt with multiple terabytes of data, but we've also dealt with smaller companies and smaller data sets in the realm of 2,000, 5,000 observations. So this machine learning doesn't have to be, I need a ton of data. You can get value even out of small amounts of data, depending on what it is you're looking at. And that's where that action, that's where that question comes in, because it's got to help the business. All right, so what we're going to do is I'm going to go over three primary areas. We're going to talk about creating things like a customer scorecard and how machine learning helps that. And then I'm going to basically give you some of the techniques. And then I'm going to talk about a specific case study or case studies that we did in this particular area. So we've got three sections. This happens to be a popular one with customers. The gopher is actually, it took me a long time to get that picture. I was at a retreat somewhere and he was there all the time. I could never get the picture. I finally got it at one point. So he gets to go in my presentations. So what's the best way to classify our customers? You have a ton of data about your customers. You know where they are, certain demographics, their position, maybe how long they've been in the company. In the case of students, where they came from, what classes they're taking, or high school, GPA, whatever it is. You have a lot of information. The idea is to leverage that information, but it's very, very difficult when you have, say, 40 or 50 or 100 variables associated with that customer or student. So one of the things that classification does is it enables us to create more effective marketing campaigns. I can target my customers better if I know these customers with these attributes tend to buy more from us or tend to stay longer with us. I can deliver more desired products. I know customers with one certain classification will buy high-end products or maybe Microsoft solutions as opposed to AWS based on their environment that they have. We can increase opportunities for cross-sell and upsell. They buy one product, I can classify my customers, hey, this person's a prospect to go after something else. How do I give them that value? And identification of influencers, which is another thing. Within customer classification, using another technique, social network analysis, which I'll show you a little bit later, we can actually identify who within a particular network is the target person who will influence 15, 20, 30 other people to save me on marketing costs. Instead of me blanketing everybody and it costing me, let's say $6 for 1,000 people, I can actually take that $6 and target, say, 100 influencers or a little bit more to reach 10,000 people, because those are the people who are doing the marketing for us. One of the things with classification that's important is there's two types of classification. There's these things called state attributes, which are things that you know before the prospect becomes a customer. Regardless, they will not change. Male, age, maybe income level, position within a company, etc. And there's a lot of that information. The behavioral attributes is another way to classify. Once they start interacting with you, once they've purchased, I can now classify them a little bit separately. And I can classify them in the first week, first month, first couple months, depending on the industry that you're in. And we can create any levels on the pyramid we want. I could do high value, low value. We always like odd numbers. We want a high value, mid value, low value. The reason is because that mid value is something we would analyze a little bit later to push people either up or down. We want to identify them. One of the things in machine learning that you'll hear, oh, we need machine learning, AI, and probably being dumped on. They're all statistical techniques. They're all statistical methods with some computer science. The difference with machine learning is you constantly run it with new data. Every day we get new data, we run it again. And the coefficients or the numbers that move these items up and down begin to change. They change. And so what does that mean? As your environment changes, the coefficients change. It's telling you there's some trend that's happening. The more data that you get, more subtle changes you'll see, but you will see them over trends, and you can see them sooner. How soon? If you do things on a weekly basis, you'll see things roughly in a week to 4 weeks. You'll see these changes. If you do things on a daily basis, it may take you a week, 1 day to 7 days, but you can do them on an hourly basis. I'll talk about one of the clients in this section that basically changed their entire operation because of it. So how do we do this? We classify the state attributes. We set our demographics, behavioral attributes. What was the quantity of my first order? What did I order? Right? Did I order the big item? Did I order the small item? What does that mean? Well, if I ordered a small item, I might be testing you out. I might be trying to see who you are. And I have no longevity. If I buy the big thing, I may have already made a decision. And I may be the high value customer at that point. Once you have your attributes, you're not starting your machine learning process. You're actually creating new data from it. But, for example, if you take a date, we explode a date out into about 12 different variables. Day of the week, month, quarter, month of the year, day of the month, first half of the month, second half of the month, whatever it is. Because we're trying to find out, are there any inherent patterns in when they did what they did? When you include time, we get a whole bunch more. And that's ultimately important. Why? What if when you start talking about things like purchases? I have a person who purchases between 12 midnight and 6 a.m. That's telling you something, especially if they do it consistently. And so therefore, that might be an attribute that goes into my classification model. Maybe, maybe not. The mathematics will help identify that and coordinate that. The next one, if you have anybody doing any type of data science, it's one of the things that's missing, determine distributions. This is about as statistic-y as I'll get. Everybody remember our friend, that bell curve, right? It's not the only curve. There's a bunch of them. There's curves that are skewed to the left, curves that are skewed to the right, right? There are things that are called discrete, which are basically 1s and 2s and 3s, but the numbers in between don't mean anything. And it's important to understand that because the techniques that you use will be informed by the distributions that the data actually is. So it's important. The third one is locate outliers. We have to identify, there's always points somewhere in the system that don't belong. Now, they don't belong because either it was a mistake in coding, it's a mistake in the data that gets transferred, or someone did something they should have. We actually saw this one time. Big water company, $1 billion in revenue in a single day. The next day, there was a minus $1 billion. You can tell that those data points don't belong. They got to get removed. And so it's important to do that because it can affect your classifier. And once you've got all that done, you identify the various techniques that you're going to use. This kind of looks like my midterm. This is what students do, right? They use all these techniques in a variety of ways. Let me just explain a couple of them. Logistic and ordinal regression is a way to predict a 1 or a 0. What did they buy? Will they not buy? Are they high value? Are they low value? Ordinal classification of 1, 2, 3, 4. Are they going to be a rank 1, rank 2, rank 3, rank 4? That's what that technique does. Another popular technique that you'll hear moving 4 down is something called k-nearest neighbor. K-nearest neighbor says, I have all my data points all over the place, and I get a new one. Plug them in. Who are you close to? My 10 nearest people will vote and say if 8 of them are green and 2 of them are blue, then that point that we just put in will be green. They voted. It says that's who they are. And we can constantly put new data into the mix and see what the new votes are. You have things like decision trees, things like k-means cluster, and more advanced ones. I want to talk about the last one, neural networks, and I'll tell you why. You've all heard of the term deep learning, right? Everybody loves the term deep learning. You need to learn deep learning. Deep learning is based on these neural networks. It's based on these multiple levels. The problem with deep learning, the problem with neural networks, is one of the researchers actually said something very good. He said neural networks are the second best way to understand anything. The best way is to actually understand it. Meaning, neural networks, you cannot understand what is happening. It gives you an output, nothing else. That's why it's great for handwriting recognition or audio recognition, because I can pump data into a neural network, into these multiple deep layers, and it will come out with a result and say, I think that's a 9 that someone wrote, or I think that's an 8 that someone wrote. And that's what it does. But it won't help a marketer figure out, how do I go after this particular customer? It won't help my finance person figure out, if we do these things, I'm going to increase my investment revenue. It won't help a credit score company figure out, hey, this person is a huge risk. It may come up with the right answer, but it won't tell them why. And the why is just as important as the fact that it is. So here's an example of what we did. We worked with a company that basically was looking at their marketing campaigns. They had a bunch of marketing campaigns that aggregated into their customers. All these customers bought something. It would take them 7 weeks to determine the effectiveness of a marketing campaign. They had to wait for 7 full weeks of data before they could figure out whether or not it was good, high value or low value. That's all they could tell. What we did was we classified the customers. They asked us to classify the customers, any customer, regardless of the marketing campaign, classify them into this diamond, silver, bronze, and zero. I have no idea why they skipped gold, but they did. And we created this 4-level classification. Our first phase, we were able to do it in 5 days of activity. Once we had 5 days of state and behavioral results, we could classify them with that 5 days of activity. The second phase, when we added more variables, we could do it in 36 hours of activity. So now, instead of it taking 7 weeks to determine the customers who were good, we could do it in 36 hours. And that was critical, because then what they could do is they go back to their marketing companies and they literally start bidding or saying, we want more of these customers, we'll pay you higher or lower. Yeah.
What kind of data points are being collected?
So for there, it was, from the state perspective, it was things like the browser. It was things like the browser, location, IP. They had DMA from, who's the company that does the DMAs? Nielsen? Nielsen DMAs, those regions. So they had a lot of location information and anything else that the browser they could collect on in the product that they chose. The behavioral aspect was, what time did they download and how many clicks did they do with that particular product in the first 36 hours, along with some other attributes. So we could literally monitor their behavior in the first 36 hours, and that's what made it work. And that's what added to the entire classification. They could go back within, and the key by 36 hours and really 5 days was, they had 7 days to make adjustments with their marketing. So they needed to do it in under 5 days so that they could analyze it on the 6th day and rebid on the 7th day. By getting it in 36 hours, it just expedited everything. The thing that this did to the company is they were doing everything in weeks. Their entire view was in weeks. But by doing this, they changed everything to looking at things by hour and groups of hours, roughly every 6 hours. Does that answer the question? Cool. Any other questions on this?
But the first portion was, the setup was 5 days. Right?
No, what happened is the first phase was when we got data.
The initial data.
Right. It's basically, and it would constantly run. As long as we had 5 days worth of the data for that customer, we could classify them well with the behavior. Right. Their first 5 days of activity.
But afterwards, it would take 36 hours of continual data.
That's correct. Once we got 36, so in reality, you can get rid of phase 1 once you got phase 2. Once I got 36, I could classify them. We actually got it down a little bit better. We did a 24-hour. The problem was it dropped about 8%. We had a little bit more error by about 8%. And we said, look, we think you should stick to 36 hours unless you want to go with 24. They actually chose both, but they ended up with 36 hours as being the right one. And this led to increased marketing efficiency. They reduced their costs because now they weren't guessing. They were able to get more platinum level customers or diamond level customers. And it improved their targeting. They could literally tell their marketing groups, this is who we want you to go after. They couldn't predict the behavior with the model, but they could predict the state, which would increase the likelihood of getting higher prospects, which is what they wanted. Yeah.
How did you make sure that the coefficients didn't change?
So the coefficients constantly change. So that's your machine learning piece, right? So the coefficients change, but they move up and down. And then what it does is it gives you a perspective of, hey, this is still diamond, this is not diamond, and so forth. And so each week they would reanalyze. The system did it automatically. So once you had the coefficients, what we would do is we work with the company to show them how to reanalyze the coefficients, because if you have an environmental change, something that drastically changes, and there was one a little bit after that, way after this actually, Google changed their algorithm for the downloads. So once they change their algorithm on the downloads, the environment changed. We have to go retrain a whole new model, new variables that will come in, but the effort is a lot less because you already know some of the aspects of it. The other thing that's interesting about that is when we do forecasting models, we see that a lot of times where if you do a revenue forecast, you're kind of somewhat beholden to environmental economic factors. So you may have a shock in the market, or you may have a shock in the environment, unemployment kicks up for whatever it is, and it affects your forecast. The thing is that if you do it over and over, you'll be able to manage those effects on your forecast model because you can retrain based on the effects. You can go back, retrain, reestablish new coefficients, and then move it forward from that point. So all of that is feasible. It's how you handle these things that's most important. Now, is classification an end? The answer is no, right? So does the end justify the means? No, it's actually not really necessarily an end. It can be used with other things. We use the classification to predict the total number of customers that we're going to get that are going to be platinum level or low level for revenue. In this case, we actually did something a little bit more unique. We took external data that the company had from a company called Exalate, which had 1,700 rows. From that, we created a profile, which I'll show you in a second, about 5 or 6 profiles, not 3. Then we matched these profiles back to the classification of high value, mid value, and low value. And the reason for that is this was an effort to get more specific on the state attributes of a customer that this external company had. And we integrated it into something called an intra-individual profile, which is something that we've developed further. We've developed this whole concept. Within a single individual view, you have a number of attributes, things that you buy, things that people vote for, things that people associate with, they go on a trip and so forth. That's what the Exalate data was trying to capture. And we can create this map for every single individual. And what happens is that if we know that you're a platinum customer or a zero customer or a bronze customer, we can look at what are the same things in that map associated to those level of customers. And we literally can say, if you see this one particular attribute or these 3 attributes together, your probability of becoming a diamond level customer goes way through the roof. It's to really look at an individual constantly that comes in and all these things shift at every single customer level to learn how the profiles are different and how they affect sales downstream. So it's integrating multiple techniques. It's pretty complicated. This one actually, it would take us, our first initial run took 36 hours to run because it's so complicated. We were able to move it on and get it to run faster. This is the type of thing that goes on a cloud solution where you can literally ramp up the processing power that you need to get some of the initial results, and then you can drop it down once it starts moving into a production environment. Okay, so that's kind of classification. So now we're going to talk about product mix. So the objective of finding a right product mix is to optimize the opportunity of selling everything, okay? This is extremely difficult when you have 20, 30, 50 products, even in classes. What classes are students going to take together? Is there something that matches together in terms of their interests, as an example? If I buy Azure, am I going to buy the Office 365 at the same time? What are the things that people buy together that they're more likely to buy together? If you only look at 2 things, it's kind of like a correlation. Say, oh, well, this one went up, so this one went up. But it neglects the entire richness of every one of those 50, 100, 125 products or services that are being sold. Here's where the problem comes in. It's not statisticky, it's just some charts. Just warning everybody, okay? I have something that looks like this on the left for product 1 and something that looks like the left on product 2. They look like they have a bell curve. They look like they're a wave. It looks shifted. These are actually different distributions. They are different. And what happens is some data scientists will neglect looking at these distributions. They neglect looking at the shapes of the curve, which are very, very informative for a data scientist. What happens is in machine learning, as new environmental variables come in, these waves shift. They shift up, they shift down. And that in and of itself is informative. It's very informative because it tells you what's happening in your environment. When you put the two products together, your probability shifts for the purchase of these items. When these two are purchased together, it shifts all the way up or it shifts down. And it stretches this curve out. But that's only two. We can't visualize things more than two. But in mathematics, this could be 40 or 50 dimensions long. Something that you just can't visualize, or if you're in Star Trek, maybe you can because they seem to do that with space-time continuum. How do we do this? We used multiple things like principal component analysis, factor analysis, Bayesian inference, multiple correspondence analysis, which is specifically for categorical variables. Products, yes or no. Product 1, 2, 3, 4, 5, product this, what goes together? We actually did an analysis using this, where for one company, when people downloaded the product, we could tell what DMAs are specific numbers, 532, second New York, or whatever the numbers are. Each one of these is in this map. And what happens is that all the products are categorical. There's no continuous numbers. There's no 100,000, 200,000, 300,000. It's just either is or isn't. 100 downloads from this area, 100 downloads from this area. We were able to identify patterns with multiple correspondence analysis, and we did it to the CEO and said, it seems to be that the top 5 areas together when downloaded were San Diego, Norfolk, Oklahoma City, Portland, and Sioux Falls, South Dakota. And he's looking and trying to figure out why they were all connected to each other. We said they're all military bases, except we didn't know Oklahoma City. We didn't have time to look at it. Turned out he was from Oklahoma City and said it's Eldrin Air Force Base. I grew up there. Okay, that was a unique little process. But the key is that the Amazon services, IBM services, they can't tell you why. They can tell you that these are together, but they would never make that connection that it's Air Force Base, military bases. And that's ultimately one of the interesting things that real analysts need to do. And that technique allows us to do that, allows us to see that. So here's an example for this product mix. What we took was 36 mobile applications that they had. And customers' selections were aggregated. We know that they downloaded multiple ones of these mobile applications. And we take a look at all the ones where the customers purchased this or purchased that, whether it was free or not. They had free applications and they had purchased applications, and we integrated them together. And we create all this up top here. We create this stuff. I'm going to pull this out because I can't see that. So we create this chart up here, which basically gives us how many relationships were, how many items were purchased or free downloads between the customers. When we do that, we can create dimensions of products. We can start seeing how they pull on each other. And so group 1 represents, a specific product mix at one point. Group 2 is a different product mix. Same thing with group 3. And we can create n number of groups, as much or as few as we want. And using principal component analysis specifically, we can identify which ones are of real value. We then take that information, this group probability, for each one of the groups, group 1, 2, 3, 4, and locate the probability of them being in an app. We then go back and include this into the classification so that we can do a prediction model to say how many products are going to be purchased by people in group 1. Group 1 could be my platinum level customers. If they're platinum, are they going to end up buying 2 or 3 or 4? Do they end up buying a free product first and then, or straight purchase? And did not buy a free product, but download the free product and then buy it, right? Or do they go right after the purchase? So a lot of different things can go over there for the specific opportunities for the customer classes. But again, we can go even deeper. And we can take this notion and using social network analysis in for a different way, we can literally create maps that look like this. This is half of the chart because it looks a little bit better. I basically drew this out. See this one green dot? We have all these arrows going out. We can weight all of the interactions between that particular green product here and the products associated around it. And we can map all of these interactions. This represents a product mix. Whether you're going to a store, right, and in the first aisle, see, my first aisle is produce. So I got to go to the first aisle and I go get produce and I go grab peppers, right? And then I go, well, where am I going to go next? All of those interactions between that shopping list are interesting because it's developing a pattern. I identify that my first entry point here is this green one, and it seems to influence the entire network, which means if you're a marketer, try and push that product, especially to a particular classification, because it will lead to more downloads. It becomes the influencer in your network, whether we're talking product or whether we're talking people. I can have people influencing a network. I can have a product influencing a network of the individual's cross-sell opportunities. We can also identify isolated nodes. So basically products that might be out here, right, where they're not really connected, those are isolates. And that might be an interesting problem to say, this product has really no bearing whatsoever. Maybe it has some downloads and it seems like it might be okay, but it doesn't influence anything within my network. Then we can go and ask why. So we did this for the same company. We used it as a second phase. And what we were able to do was we asked which applications are better at cross-promoting other applications. Therefore, which application should be our target entry point? Who should we target? And we end up with charts that look like this. So this is obfuscated a little bit. There's codes in there that mean absolutely nothing, but the categories are things like utilities and entertainment. And I can start seeing which bubbles appear more important. And then you have these things. So we created a circle here because we noticed that there's what's called a circle diagram, where there seems to be this link between this product, there's a line to this product, and one to this product. And they stand out. So that's meaningful. And we can do this over time. We do this each day or every week. In this case, these were done every week to see the effect of the campaigns. We could then use that to predict in terms of a machine learning standpoint, hey, this is what's going to happen next week, assuming these attributes remain constant or assuming you change them to be these attributes. What's interesting here is that we have this feedback loop here between these two products. They happen to be in the same category. So they started to look at it, and it was weird because there were two weather products. And then they had to ask the question, why would people download two weather products? Then I looked at my phone. I had two weather products and didn't even realize it. I just downloaded two weather products. And people apparently did this. So this was an interesting aspect of this, in addition to the predictive learning that it does. You also have another one. We have what's called a star network out here, where this node seems to be integral to about 5 and other nodes. That's fantastic. But this one is actually more interesting because that node is what we call a boundary spanner. It spans these two sub-networks. Why is it doing that? What is causing it to do that? Right? And what is the implication of marketing that particular product? And so we had over thousands, about 1,600, I think, or 1,400 networks that we had to analyze week over week over week over week.
So that point was in both circles.
To see how that point was in both circles, what was it doing?
Right.
What was the product? And here it's a fairly large bubble, and I think it's in utilities. This also indicates to the company, maybe we need to produce more utility applications. Let's come up with more. So it's giving insight into product development. Any questions so far? Yeah.
That's what your inputs were on this network.
On this network, we had the product, we had marketing spend, we had downloads, clicks, and I think 3 others. I don't remember off the top of my head, but I can get that for you.
So it's attributes about the product.
Attributes about the products, like utilities, longevity was another one. How long was it out there? We gave everyone almost the same amount of time as best as possible to get clicks, the amount of marketing that went into each one of them, how many downloads, how many times the message came across for the cross promotion, and so forth. In that, R. Everything was in R. Most of the stuff that we do, even though we're tools agnostic, our general preference is R and Python. For social networks and stuff like that, you could use Gephi, you could use there's another tool that's popular, that's something I can't remember off the top of my head, NetGraph, I think. It doesn't matter, but we like R and we like Python. One of the biggest reasons is this. When we run our application in R and Python, regardless of what it is, we get a result. We take that result and we dump it into a database, because then the information can then be analyzed by, I'm looking for Josh, by Power BI. We're storing it in the cloud, right, for a database. It can expand or contract as needed and so forth. And so all of those tools are important. Now, Power BI I don't think does this. This would be a specialized graph tool, but for all of the other things like forecast models, predictive models, revenue forecast, time series, even classification categorizations, all of that gets dumped into a structure, into a database, and then you can consume it however you need to. And you can integrate it with other data that you have, like your marketing spend and so forth.
Does this data exclude those out of the waypoints and everything else also? Or
Like for outliers?
yeah.
Yeah, so what will happen is this. We have statistical techniques to determine which outliers should be removed. In
Right.
some cases, we remove them. In other cases, we do not. Sometimes we just flag them. But before we actually implement it, we really try and understand the effect of an outlier. And if it doesn't really have much of an effect, we'll leave it in, because it won't affect the coefficients that much. Okay, so that's product mix. So the next one's like natural language processing, because this is another big thing that people like to talk about. Natural language processing is complicated because it really requires some good processing power to take text and create various classifications. There are a number of libraries that are already out there that actually will classify certain words, certain keywords, whether or not it's an adverb, a noun, and so forth, and it breaks the structure of the sentence. So we leverage those as much as possible. In some cases, we will actually do a separate classification of words because they're so specific to an industry. So what can you do this? Companies use NLP to develop automated responses to questions. So we know a company that we're talking with about doing that. Understand the sentiment of customer responses, or understand the sentiment of something, whether things are happy, sad, anger, because we can actually use those numbers with something else and predict the effect of a certain sentiment. We're going to show you that. Assess the effectiveness of customer service responses. So if you have marketing information or a customer service response, you can actually use sentiment analysis or subjectivity, objectivity, positive, negative, all these different aspects of the actual email or the subject, and see what the response was from the customer and measure its effectiveness. And you can also determine the performance of marketing messages the same way. It's not just a random set of information. It is, I'm quantifying the information that's in the message to see if there's a better effect or not. So in the case of sentiment analysis, we have 90 plus measures that we could do, right, from some of the libraries that we use. Positive, negative, subjective, objective, uncertain. One of my favorite is litigious. It actually will figure out whether it's litigious or not. It's like everything today is litigious. Surprise, trust, joy, and so forth. And we literally will send in some text, we will get some message, and then we will do something with those numbers. So a simple one might look like this. Working with a news organization, basically we had some titles that they had. The FBI joins criminal investigation into the Boeing 737 MAX certification. Plug in the numbers, we plug in the text, and the library gives us these sets of numbers. I haven't given you a whole thing, I'm just giving you a small amount. It's considered, there's anger, there's anticipation, fear, it's negative. There's no positive, no sadness, no surprise, no trust, no joy, and it's a negative sentiment. That's all it is. That's great. We could do this for every single article. What we also did for them was they wanted to figure out how they could get onto Google News a little bit more. So Google News, they figured, has an algorithm. They also figure there is a method to their madness of what they're going to choose beyond just the outlets, the New York Times, Wall Street Journal, and so forth. So we took a series of articles that were just published over the course of a week. We literally ran it, pulled the articles, etc., over and over again, stored them. We said, if you were in Google News in a particular category, I don't remember which one this was the average set of numbers for all of the articles that were there. So we tested things out. We'd use these, and we would compare them to articles for the blog, not the blog, for the news site that would actually get onto Google News. They had a couple of articles, and they would match. When certain attributes were there, they matched. So what they did was they said, okay, let's take those sentiment scores, let's retain them for every single article we write. This was only on titles, not on the body of the actual news article. But you could do it for that. We looked at the Google Analytics for that particular article, for that particular site. I think, by the way, I see people taking pictures. They're going to get you a copy. I just realized it. My students do that too. They take pictures. I said, I'm going to give you the PowerPoint. You don't have to do that. Save the film. Tell how old school I am. There, it's like, you know, got to put the film in. So we took the Google Analytics. We took all the sentiment information, and we created predictive models. We could actually use the information about the article, when it's published, what category it was, use the sentiment into a predictive model to figure out how many page views was it going to get. Okay? It's a little bit harder in this case because there's so many other variables that we have no insight into, but it gave them a good estimation. However, what they really liked about it was we could take all of that information and look at a news story and reassess the titles to see if the titles seemed to line up for the category that they wanted to get into. And if it didn't, it would basically give them an indicator saying, we don't think this title is good. You know, and they had different levels of what they thought was good or not. And there was a lot of bias in the organization, in the news organization, about what is right and what's not. So we spent a lot of time proving the mathematics to them, non-mathematically, of course, just by saying, this works, this doesn't work. Here's an example. There was a belief that every August their traffic drops. We did an analysis. It's not true. They said that can't be right. So we spent literally a week with them going over why what they believed, their intuition, was not generally correct. But we also wanted to figure out why they thought it was the case. And turned out the bias was because they saw other sites drop in August, but it didn't happen for theirs. So that was where that bias came in. So here, they would write a title. We could actually quantify what that title was in terms of sentiment, and we would basically give them the score. The next phase to this, which we haven't started yet, is they want us to develop an AI bot that will actually create a new title based on the same information that's there. So we would try different keywords and so forth in the title, try and create the title automatically and say, here's a recommended title based on that, based on the scores that they want to get. Okay? You can also use this. A healthcare firm wanted to use NLP for a little different problem. Their problem was when they recruit a doctor. When they recruit a doctor, it costs them a fortune. If that doctor does not stay with them for at least a year, they lose money. That's a big problem, and it's a lot of money. And they had people have high turnover at within 3 months or 4 months. They lose a lot of money on the recruiting. So what they asked us to do in a pilot was basically take information from their resume, from LinkedIn, things about the school. We aggregated additional information. How long were they at a place? Pull all that information and develop a profile based on what they wrote, based on what school they went to, based on how many jobs, what their longevity was, to see if the profile could actually tell them the possibility of retention. Because they had doctors already, they had LinkedIn profiles, they had resumes, so we could actually utilize that information to determine from a predictive perspective whether or not a new entrant coming in would actually be able to be retained, and so forth. And so this items that were used, things like school, previous tenure, location, were they in a big area, small area? Did they want to go to a big area, small area? And they actually had some other information that we could incorporate into it as well. But that's another technique of using NLP. Does anybody have any other any questions before I go on to the last? I'm going to talk about 2 of these out of the 4, because I know we're already at 1 o'clock, so I don't want to take up too much more time. Does anybody have any other questions? Does anybody see how this can be used in their organization? Anybody have any ideas of how it could be used in their organization? Anybody alive?
I just have a quick comment.
Yeah.
Quick comment.
News media
Oh,
case
sorry.
is
Hold on
actually-
1 second on the phone. We'll get you.
The
Go ahead.
news media case is actually very similar to what Dow Jones, Wall Street Journal is doing,
Mhm.
except that we're training the machines to actually determine what a new article's sentiment is
Mhm.
based on the 750 articles has been read by humans.
Right.
And scored the sentiment.
Right. So a lot of the algorithms for those classifications will require some human intervention. Some of it has already been done, and so the libraries are available. And I would also encourage you to include those into the mix. Any data point that you get, regardless, should be included into the mix. And then either allow the data to drop out naturally or determine why it would be flawed in the first place. But Amazon does that. That's why they have like thousands of people all over the world listening to your conversation on Alexa and classifying it.
Also see with human resources on the other side of the doctors. I mean, every company, has to hire people. And they want to know if the longevity, how long it's been there. I mean, I have their positions in my company, like hire people. So human resources in my department. But that should be for every vertical.
Yeah, just to add to the NLP and those libraries, I mean, Microsoft has a whole, database full of core services for NLP. And if you're in any of the Microsoft cloud technologies, whether that be in M365 Suite or even in Azure, you'll see, if you haven't already, you're going to be incorporated. So if you're using Dynamics CRM, you're already incorporated.
That's
If
good
you're using
about Microsoft.
M365, you incorporate it right into your email clients, right into your SharePoint, your OneDrive, or your Teams when you collaborate. So you'll start seeing more of that if you don't already see it.
Yeah, we actually have, to jump on that point, we actually have a product and a project that we're working on with another healthcare firm. Basically, they're looking at the connection between emails within the organization. They want to know, if I create these connections, these social connections using email, and I find people who are more central in a network, does that tend to lend itself to being promoted or higher raises or something else? Or the opposite, if you're isolated in this email, which means they're making an inference that being isolated in emails means you're isolating yourself completely from the work or from something else. Does that tend to lead to lack of the promotion, lack of incentive, anything else, or even people want to leave, right? Do they see that? And they want to do it over time too. So they want to see if someone left, they want to look at the last 3 months or the last 2 months to determine if the emails dropped off in terms of their central network. Did their function change in terms of their communication, which is a predictor of them leaving? And we integrated that with the Office 365 solution. So we pull the emails, populate it into a SQL Server instance, and then we run our code to actually do the analysis and populate it back into a SQL Server database, but the display is not in Power BI, it's in another tool. Yeah.
How do you account for cultural bias?
You'd have to encode that in, right? So somehow you'd have to have that piece in there. So in this case, like for the local health firm, we're going to assume that there isn't one because they should be all homogenous. But if you're going to include cultural bias, right, and you have the demographic information, so you may know where they're from, you include that as a variable in your mix. You still do the social network, but in the same way that we did the categories where each one was a different color, right, you may use those colors to determine which culture they're from to see, do they begin to separate naturally? Am I communicating it with everybody within the same cultural bias or even subcultural bias, right? So you could things like, is there a natural thing that occurs between Democrats and Republicans within an organization in terms of their communication? It's very possible, right?
Specifically in the sentiment analysis, culturally, some wording, for instance, might be interpreted positively
or negatively.
By one.
That's based on the libraries.
Okay.
So a couple of libraries do have some cultural aspects to it. The libraries that we used here did not, because this was a pure US base. There was someone on the phone who had a question. Did you have a phone on the question? Phone on the question? I'm good at math. Go ahead.
Yeah, your last reference, right away I thought of Cambridge Analytica.
Yeah.
What I wanted to determine is the predictive analysis that we were discussing so far. I mean, you touched a large portion upon advanced analytics, right, and predictive analysis based on, consistent data sets, right? As long as the input is consistent behaviorally, obviously the output is then going to be on the same scale of consistency. My question is where the AI portion comes in, where it has to determine or be non-deterministic. Can you touch a little bit upon, I guess, the algorithms that are involved with that as well, in terms of making these non-deterministic predictions? Is it based on timeline? Is it based on dissimilar data sets? I just want to know a little bit about the AI portion of it.
So the AI portion basically extends a lot of the machine learning pieces, and depending on which scholarly papers you read, one is a subset of the other. It doesn't matter in that case. But let's say for AI, the whole premise of AI is that you cannot tell the difference between a human doing it and a computer doing it at its basic premise. So in the case of like creating a headline, right? If the automated system produces a headline that is reasonable, that is significant, that you cannot tell who actually did it, was it a human or the robot? That's your artificial intelligence. Customer response. I know one of the education companies is basically looking at, for their instructors, instead of having the questions go directly to the instructors, they want an automated system to look and determine what type of question it is from the text, not only do routing, but actually provide a first level answer or first level response to the student. And that would be a form of AI. Does that make sense?
Yes. So you're pulling data basically from different sources of input and then coming to that determination based on those different sources.
Correct. And one of the other things that you can do, which is another aspect of this, which is not widely talked about, but is part of the AI and ML realm, is simulation, where you actually will create data sets based on probabilistic methods and plug them into your equation to see what if. What if the number of my platinum customers drops by 5%? What does that do in terms of the model? How does that change in terms of a particular attribute or coefficient dropping off or being more important? So simulation is one thing that they don't talk about, but it's something that we advise a lot of companies to do. And that's what you see with like weather. You know, weather is a form where they do hurricane prediction models. There's simulations that go into that figure out where the item is going to go based on their models.
I was just going to subsequently say, based on those predictions, though, what is your coefficient for reliability? How do you make that determination?
So there are a number of ways to determine whether or not it works, but it's going to be based on the data, the new data that you come in, what your prediction was, how well the error rates were. There is sensitivity analysis, like are you more sensitive to one particular variable or not? That's one of the reasons why with the weather you see all those spaghetti diagrams, because each one of those models is sensitive to certain features within the data set that they have. Does that make sense?
Yeah, somewhat. Yeah.
At the end of the day, your biggest sensitivity measure is going to be how accurate was I? In terms of the actual error rate, how accurate was I with this? And as the new data comes in, does it maintain that level? Does it increase in terms of error, or is it decreasing in terms of error?
Does it review that data? Does it review it after the
Yeah.
output results?
Yeah, it should review it. Either a human needs to review it, or you can automate it, because what you can then do is if you know other variables belong into the mix, you can write code to actually incorporate it and see what would happen. This
Right.
is
Right, but the idea behind the AI obviously is to alleviate human error. So the question is based on automation and solely on the automation of the logic of the algorithm.
Yep.
When it revisits that error, where's the accuracy? In other words, how does it assume it was the error, and how does it correct itself?
So when you put it back into the model and it recomputes, you'll get the error, and then you have rules in place to actually determine whether or not it's going to try any number of combinations of variables to determine what the new error rate is. The other thing I would advise, by the way, is we talk about a lot of pure automated solutions. Be very, very cautious of it, because I use the term, IBM Watson had the medical for cancer, the cancer doctor and so forth, and they've kind of toned it down a little bit. I think Memorial Sloan Kettering is no longer using it directly. I heard recently that they put a pause on it. There is what we haven't been able to do in the industry, and it's one of the things that is in the edge, the bleeding edge of artificial intelligence, is this notion of creativity when it sees something it has never seen before. I know Google, I know Microsoft, they are working on this, and these are very, very high-end problems, many of which I don't think are really necessary for a lot of the businesses out there, but they're actually very good research projects. So Google actually shut down their AI tool because they started to communicate to each other in a language that the researchers couldn't understand, and they became concerned. So would I. Microsoft had Tay, which would take in tweets in for, and then try and respond back intelligently like an AI bot would do. And within 24 hours, it became a racist. And they had to shut it down, right? Because we don't fully understand. So that techniques that you're referring to are basically those where it's basically modeling itself, looking at what is going on, determining is it aligned with the data that it has, etc.
Right, right. I was more on the track of narrow AI versus general AI, but I was just questioning its error probability and what its defense is against it. Because obviously there's a large business investment that's made, right, in terms of dollars. And the question is to rely on AI solely to act as a guidance mechanism for which way the business direction is going to go is a big deal. So, that's why I question its error probability and how much reliance can you put into the artificial intelligence.
That we had that similar question with a company that's doing the risk models. And one of the things they said was, well, how do we know it works? And the reality is that is actually not even a technical question. If I could run the code and show you that there was 1% error, right, consistently, and it would fluctuate, say 1.1, 1.2, 0.9, wouldn't matter because they wouldn't necessarily trust it to begin with. Over time, they would trust it. What you're basically referring to is ultimately a trust factor. And I would say there's no number that could quantify that. There's no number that's going to directly quantify to say, okay, I'm just going to let this run my business or run a certain aspect of the business. Yeah.
So it's safe to say then you would use it solely for short-term deterministic predictability. You would not use this over a wide scale.
If you had 12 economists in a room, you would get 13 different opinions, right? And so even humans trying to predict further out have the same exact issue. And we're the ones who are teaching the AI tool.
Right.
Go ahead.
So at what point is this more novelty and experimentation versus actual thing we rely on? Like, it's one thing, revenue is, there's some level of predictability that if I went to my CFO and showed him how my numbers line up, how AI numbers line up with our numbers, and as Stu pointed out, like, go back down and dig into old clients to find revenue, things like that. Okay, fine. I could go to Salesforce and they can do that, and they have AI and smart guys working on it. But if, like, what's the paramount problem that we're stacked on here that we're solving?
Mm-hmm.
Because we all have two weather apps because one of them goes wrong. I mean, they throw out 12 hurricane models, and when you talk to the people in the islands, they're like, it doesn't matter. The whole place gets destroyed no matter which model you use. So at what point are we really going to bet on this?
So to use the weather analogy, when you wake up, do you look outside and determine the weather for the next 3 days? Or do you look at your apps, or do you get the weather report from the weatherman?
Apps.
Okay, so now if you go 7 days out into the future, when you listen to the weatherman or the apps, how much do you believe them?
No.
You don't. So there's a threshold of acceptance, and that's really the key. It's not a novelty, that I can tell you, because we've done this with companies. We've got the success factors. I'm not saying they're limited. I know other companies that do this. Even when brought up Cambridge Analytica, they were successful in what they were doing, right? So the data and the mathematics, it's math at the end of the day. So the math itself is not wrong. Where you get to wrong is inputs that go in and interpretation that comes out. That's where a bulk of this has to go in. And I tell my students, 30% of an AI ML project is cleaning the data, making sure you got the right data. Another 30% or 20% at the tail end is the interpretation and analysis, right? The stuff in the middle, about 10% is the actual stuff that we're talking about in terms of the techniques. If you just run the technique and it'll work. But it's that whole concept of setting it up properly, leading into it, and then interpreting it that's important. We never say it's 100%. But then I would challenge anybody, anything that anyone says, is it 100%? We had a situation with a client where we did a revenue forecast model, and our models were doing great. And then all of a sudden, we looked at a November, past, we were predicting it, and it dropped all of a sudden. The model said, no, you're going to go down here. And we were predicting something along the order for the future year. We were predicting something around 828 million, 830 million, and their analysts had predicted 890 million. So they said, you're wrong. I said, yeah, okay, we'll go back, we look at it. We do this. Turns out in the first month, we were right on. Second month, we were off by 0.7%. Third month, we were off by 0.6% or whatever the number was. And they go, well, can we check it again? How many times would you go to Atlantic City if I told you that we were wrong less than 1% of the time and not place that bet? They went back and they said, we forgot to tell you something. Okay, they changed the price. They changed the price in November, but we didn't have price in our model because they told us not to include price, so we didn't. And so the model became sensitive and it didn't have it. But it was right and it was spot on because we couldn't tell them why. We had no idea why.
Right, but unfortunately with businesses, we're not just talking about disposable income. We're talking about hard-earned investments and future of those investments, right? So we got to be a little more, self-preserved in that respect.
And the more unbiased the data collection and the more unbiased that the business was, because we ran the model with price and it got everything exactly where and why. We saw exactly what was going on. But their analysts and everybody predicted that if they raised the price, they were going to get rid of the bottom feeders and literally extract more money out of the top guys. And that's not what happened. And econometrics actually would have told them that's not going to happen. And so that's why it's a balance. Sorry. Yeah, sorry. Go ahead.
Well, it actually seems, I think it might tie into the last several minutes here. It's like, it seems like explainability is a really important thing. If you're going to be automating this, if this is really, as it becomes more of the fabric, being able to justify, being able to explain what's going on is really important. Like somebody doesn't get a loan because of the model, and that you need to. It seems like you need to be able to know a whole lot about what the shape of the data were at a certain point in time, and so. What are you guys doing on that sort of, traceability, explainability side?
Yeah, that's one of the reasons why, like at the beginning, when I talk about understanding the data, understanding the distributions, where the techniques are sensitive to what particular problems. And I tell my students, and my team does this as well, never rely on one technique. We're a detective, right? So we're collecting evidence to support some presumption or something that's going on. But even detectives, they may gather all the evidence, but they don't have enough for a conviction. They have enough to go to trial, but not enough for a conviction because something else may have been missing. We try and go through all those steps. I tell my students to do the same thing. Understand the data, understand the outputs. What could be causing any ill effects? And try to actually predict if there's an ill effect, where would it be? So we may not see anything in the data, but if there was one, what would it be? And so we start analyzing all of those different perspectives. And that's all, that is interpretation, but it's also an understanding at a deeper level what those techniques are doing. Does that answer the question?
Yeah, I mean, it just seems like once something is in production and driving decisions, you need to be able to explain. You're going to be challenged to explain why decision X came out of, inputs of this mass at a given point in time. Yeah. And I'm just wondering about the almost like the pipeline side of things where you need to. Everything. I mean, these are all artifacts at some point. I think
yep.
You need to be able to. You need to know exactly what went into it.
You need to know what went into it. You need to interpret the results out of it. It's like a pilot, right? That has all of this heads-up display, has all of this information. Put it on autopilot. The autopilot can move, but something may go wrong because of the data that's being input, and then the pilot has to basically figure out what is actually happening, make the assessment, then make any adjustments that are necessary. Cut engine 1. Or turn off the autopilot, or whatever it is. You still need some sort of pilot making sure that everything is running well. And that's why when we go into a project, we train the folks to actually look at it, and they rely on us, with service contracts and so forth. Yeah.
I think one of the biggest problems is going to be the computing power as far as all these calculations. I know with the cloud it's become easier, but I think it's going to be get harder as all the calculations come in.
I think for most of the clients and most of the projects that we've seen, computing power hasn't been an issue. We've been able to scale up. One of the companies that we worked with, especially for the larger data sets, I mean, in their case, they actually gave us, which is really cool, a 36 CPU, 800 gigabyte RAM machine, right? That they had. I asked them if I could keep it in my house, but my wife said no. So we got a dog instead. So computing power shouldn't be a huge issue because you should be able to scale, cluster across different things. Where you'll run into a problem is where you need massive amounts of real-time processing. Then you have to code in parallel. This is where the computer science portion of this comes in. Then you're writing code that runs in parallel, that literally can distribute its process over multiple systems without not relying on the operating system to do it. Yeah.
In these kind of projects, you would recommend to rather start with many data points and then go down and reduce it and just take out the ones that you don't need?
So
Or
normally-
start small and then grow.
So when we go in, we ask them, give us all the data points that you believe are relevant, and even a few that aren't relevant. Then we begin to determine and whittle down which ones really will have no effect whatsoever. So for example, they may believe that something is going to have value, but it turns out that they're all ones in the data they gave us. So it has no value whatsoever. And then we whittle, but before we get into the modeling, into the building of the model, we've already whittled it down or we've increased it. So in other words, they'll give us a data set. One client gave us 89 data points. We created 660 out of it. Out of the 660, before we got into the actual model building, we dropped that down to about 350 because we had to see if there were certain effects of other things because they told us there might be. And so we had to look for those.
How about data points that are not part of the database? The weather, for instance, or what people had for lunch.
A lot of it is gathered or then you collect it. So one of the companies that we're working with, we've been giving them advice on what to start collecting in terms of the data for their loan processing. And so they've been including that into Salesforce. In other cases like weather or economic events, we can pull that data from external sources. Okay. We're at 120. So I can go through the other two that I've got, but I think it's really important to understand also, this is a broad field, both from techniques, the techniques to get the data, the techniques to clean the data, the techniques to store the data, to process it, process the final results. Where does it go? But ultimately that action, the fire that I talked about, is important. You need to deliver it to your client, which is your senior executive or whoever's the decision maker, in a way that is meaningful. And that's one of the key differences that makes a successful project versus an unsuccessful one. Because if they can't understand, if I sit here and talk to you about multivariate analysis and Hotelling's T with a p-value of 0.03, okay, nobody cares, right? But if I tell you doing this over this has a significant probability week over week of winning or getting you money, that's what they want to hear. And here's how I can prove that it is. You don't just take my word for it, we prove it. So that gets into this whole cloud architecture and why we think that's ultimately important.
Thank you. Well, appreciate the presentation. For the folks on the phone as well, and folks in the room will have a copy of this presentation. So if you want a copy of it, just let us know. We'll send it out to you. I just wanted to say a few things. If you're thinking about leveraging Microsoft specifically for any services, right, whether that's their typical M365 cloud service or Azure services, you may be, depending on the organization and the business use case, you may be eligible for funding. Microsoft often has funding for us to do proof of concepts, proof of values. So talk to us. We can engage your Microsoft rep and our reps and see if you are eligible for that funding. And we can talk about doing a proof of concept if you have ideas on where you can apply some of this machine learning.
Any other questions?
Please fill out the surveys if you can. It's very helpful for us. We'll be doing more and more events similar to this and around
And if you can make the NBS second annual cybersecurity
yes.
conference, that will be October 30th, and it'll be 12 to 6. It's
Yeah,
gonna be
that's going to be a great conference. And there's going to be a lot around cloud security. It's security 2.0, right? You're not just securing your traditional on-premise environment, you're securing your cloud environments. It's re-architecting the way you do security and the way you look at security. So I'd encourage everybody to attend that event if they could. If you want an invite for that event, should be on the site. The location should be on there as well. It's at Offset. Offsite? Offsite. Offsite.
Well, marketing, Samantha will be reaching out to everyone that attended this event, so she'll send it out because there's not that much detail.
Was this helpful? Find it informative? Anything in particular you found informative? Just my own knowledge. Curious what you liked or didn't like.
I thought the product mix slide was interesting. I think it's very applicable for a lot of things that I do.
Great.
I like the first one. Always did, with the fire on.
That's one of the most, that one and the yin yang are the popular ones, because it literally gives the statement of what, which is what we like. Yeah.
It's a bit off topic, but from a social perspective, is there a concern for consumer data privacy when collecting this kind of information, especially from customers?
Yeah.
Yes.
Yeah, you bring up a good point, because that's one of the areas when I talk about security, there's security, there's compliance, and there's privacy, right? Now you have GDPR, you've got the California Privacy Act, right? You have CCPA. Before you know it, New York will have theirs. Every state will have theirs, right? And so we've been involved with GDPR for a very long time. There's a lot that goes into that, right? It's the same way you're architecting your security. You want to architect your compliance requirements. You want to re-architect as well for privacy, right? So there's a lot around that.
At least 3 to 4 years on that.
Yeah, and so you can't just start collecting data and spitting it out, right? You need to make sure the data that you are collecting, you're securing it, you know where it is, you have the right to collect that data. There's a lot of steps or requirements that go through that process. And we help, that's part of the security architecture, but you bring up a very good point.
I just wanted to say that.
Thank you.
A good takeaway is if you have data, you want to know how valuable it is, how costly it would be to analyze it. That's where the analytics can help out. And we deal with a lot of other companies. We have some projects going on right now with IoT, sampling data, different usage. We make use of the tools in Microsoft. That makes it easy to do streaming, sampling, IoT. Little different uses of data, but it's using machine learning, coming up with preventative maintenance, things that are kind of valuable for a lot of companies. As well as the new area of robotics, where we're really actually helping streamline a process, reducing in some cases overhead. That's becoming very popular too, and it's another part of the data analytics and the AI scenario. So come and talk to our reps, and we can show you some projects that have been concluded or in the process that they can take to
When you go back also, if you're not sure where this could be used, don't ask how can I use machine learning or artificial intelligence. Ask this question. If there was one thing I could know that my data could tell me, what would it be? Then you figure out the technique. Then you figure out whether or not that's how it's applicable. You don't start with how can I use neural networks? How can I use principal component analysis? If I could know one thing about my data that I don't know today, that the data will tell me, what would that question be? What would that thing be? And how am I going to make money from it? Then everything else is easy after that point. Okay? Thank you again, everybody.
Thank you. Thank you. If anyone didn't eat, there's still